Problem 14. How many ordered pairs x, y of real numbers satisfy the following system of equations? So when you have absolute values, you always want to break them down into its component parts, which is positive or negative. So what I mean by this is, what is this simplified? Well, take the square root on both sides. So you get absolute value of x plus absolute value of y minus 4 is equal to 1, or absolute value of x plus absolute value of y minus 4 is equal to negative 1. Simplify. X plus y is 5. X plus y is equal to 3. So now, how do you graph this? Well, absolute value of x plus absolute value of y is equal to some term n, just corresponds with a square, right? And to understand how that square works, you have to first just digest a little bit. So that's going to be x plus y is equal to 5 when everything is positive. But then there could be x minus y is equal to 5. It could be negative x plus y is equal to 5. It could also be negative x minus y is equal to 5. So we have all these lines and we combine them together to get one final big shape. So to do that, I'll clear up some space and I'll draw myself a coordinate plane. And because the coordinate plane will tell me how many intersections there are. And intersections are solutions. So we want to find the number of intersections basically from graphing. Now to do this, y will be equal to negative x plus 5. So that means that this is going to be 5 and this is going to be 5. Right? That's going to be 5. That's going to be 5. This is going to be 5. Negative 5 rather, and this is going to be negative 5. So the final resulting shape is going to be a square like that. And with this out the way, we can move on with the next one, which is to say absolute value of x plus the absolute value of y is equal to when that's negative, so that's equal to 3. So that means you have an inner square where this is 3, where this is 3, where this is negative 3, and this is negative 3. So then you connect it, and you find that they share no common solutions, which makes sense because they don't, obviously they're equal to different numbers. But this is what's going to decide it all. X squared plus 3y is equal to 9. Well, we know that 3y is going to be equal to a negative x squared plus 9, so y is going to be equal to negative 1 over 3x squared plus 3. So one tricky thing is that how do you know if you're graphing it properly? Well, this is where some intuition comes into play, which is you don't want to graph out this. That's going to be too messy. You don't know. The inaccuracy of your graph is going to be exemplified. So just think of special points of this parabola. Think x is equal to 0. That's y is equal to 3. That's obviously the vertex. And that obviously matches at least one point right here. So we have the vertex to be right here. It has to go down. But how many points does it cross? That's the tricky part. Well, to do this, let's first consider the x-intercepts. Think special numbers here. So the x-intercept is where x is equal to 0. Well, I mean y is equal to 0. So if y is equal to 0, negative 1 over 3 x squared is equal to negative 3. Positive, positive, x squared is equal to 9, x is equal to 3, and x is equal to negative 3. Wait a minute, that's the same thing as here and here. So the parabola is going to look something like this. But obviously, we don't need to graph out any more points, because the parabola has to go downwards. And this has to go downwards as well. So it has to intersect at least once more here, and another right here. So by graphing, you don't have to graph out everything. You just have to graph out the ones that are very easy to graph, and then use intuition and logical reasoning, to deduct the other intersecting points without graphing it very neatly. So therefore, you have 1, 2, 3, 4, 5. So you have a total of 5 solutions, and that's answer choice D.